So, we've been learning about chemical reactions, and it's about time that we start identifying the different types of reactions that there can be. So, when we talk about the different types of reactions, we need to know that there are actually five types of reactions. So, all reactions are going to fall into one of these five categories. Now, the five types of chemical reactions are your synthesis or combination reaction, decomposition, single replacement, double replacement, and a combustion reaction. Each one of these is dependent on the reactant type that you have. So depending on the reactants and what's going to react, you will have a different type of reaction. This is very similar to making recipes, where depending on your ingredients, you will have or need a different recipe to follow. So chemical reactions can be thought of the same way. Depending on your reactants, you will have a different type of reaction outcome. Identifying these types is actually pretty easy. It is just a matter of identifying the reactions and knowing the differences of what's going on between them. So if we take a look at this visual, in the synthesis reaction, we have two different substances combining to make one. This is why it's also known as a combination reaction, because two things combine and produce one. In the decomposition, we are going to have the exact opposite of what we see in synthesis. In the decomposition reaction, we will have one substance, one compound, and it's going to decompose, aka break down into two or more individual substances. In a single replacement, also known as a single displacement reaction, a portion of the compound is actually going to be replaced by another element. So we are going to have something come in and replace one part of one compound. In a double replacement reaction, we are going to have this happen for two compounds, where two compounds are reacting with one another, and they're each going to exchange a portion of each other. Okay, it's going to be kind of like a rearrangement. Lastly, our combustion reaction, which everybody knows as fire, explosions, all that cool stuff about chemistry and science, uh, is a reaction where you're going to have a fuel, typically what's known as a hydrocarbon, reacting with oxygen because we know that fires need oxygen, and that's going to produce carbon dioxide and water. So we're just going to take a very casual approach to these five in terms of the type of reactants that go into determining the type of reaction that we're going to have. So here's an easy breakdown of probably the most simplistic version of all of these. And this is what we're going to focus on. So in the combination reaction, if both of our reactants are individual elements, then when they react, they're just going to combine together. So if we take a look at this example, we're going to have elemental hydrogen react with elemental oxygen, and that's going to combine together to make water. Okay, so two elements as reactants are going to lead to a synthesis or combination reaction. If your only reactant is a compound and nothing else, then the only reaction it's going to do is decomposition, where it's going to break up into the individual substances. Now, if you have an element and it's reacting with a compound this time, so that element is going to replace something in the compound, you're going to have a single replacement reaction. So element and compound as reactants will lead to a single replacement. If both of your reactants are compounds, then they're going to lead to a double replacement reaction. Now, just a note on this one, there are some combination reactions that have two compounds. Those are very specific types. Um, we will discuss that in a later video, but we are going to focus on compound and compound being a double replacement, where they're going to kind of mix and match different parts of each other. Lastly, we have our combustion reaction. Now, the combustion reaction at first glance may look like a single replacement, where we have a compound reacting with an element. But in this reaction, we have a very specific compound known as a hydrocarbon. It is a compound containing, you guessed it, hydrogen and carbon. Sometimes oxygen is also present in it. So this is going to be your fuels. It's going to be a lot of organic compounds like methane, like propane. You know, sugars can also be involved. Okay, hence the oxygen being in there, and fats. Okay, but we typically refer to a fuel as a hydrocarbon. And this is going to specifically react with oxygen. And in a combustion reaction, it always forms carbon dioxide and water. So at first glance, it may look like a single replacement, but if the element and the compound are very specifically a hydrocarbon and oxygen and is producing carbon dioxide and water, you got yourself a combustion. So by looking at the type of reactants that you have, that's going to determine the type of reaction that you're going to have.